All right, so 2,000 free response, number 4, so no calculator allowed, 456. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Okay, so the derivative, right, this is a per minute type of thing, it's 8. Water leaks out of the tank at a rate of the square root of t plus 1 gallons per minute from 0 to 120 minutes. At time 0, the tank contains 30 gallons of water. All right. How many gallons of water leak out of the tank from 0 to 3? All right, well, again, if you're going to do this, you just got to do the integral, right? The integral from 0 to 3 of t plus 1 dt. And we just got to do that integral, all right? I think of it this way. Since there is a power of 1 in here, we don't have to really worry about it, right? You can just add the 1 up here, so it's t plus 1 to the 3 halves over 3 halves from 0 to 3. And if I plug this in, I might not even simplify. I would write 3 plus 1 to the 3 halves over 3 halves minus 0 plus 1 to the 3 halves over 3 halves. And I agree, it can turn into 2/3, but I probably would just leave it. What do I get? I get. And when you're doing the non-calculator parts, right, these have to work out to be something easy. 4 to the 3 halves. 4 to the half is 2. 2 cubed is 8. 8 times 2 is 16/3 minus 2/3. The answer is 14/3. If I take a no, it has to be positive. It's how many gallons go out, right? Then it's not asking for a flow rate. This is like number of gallons. And you get a point for the limits, 0 to 3. You get a point for the integral, square root of t plus 1 dt, and you get a point for 14/3. So this first part was worth 3 points. Now, I suppose you could also do this. It'd be a lot more work. You could try to develop a formula for the leaking out. You could try to integrate the t plus 1 and create a function. And that method is shown, but that'd be so much work. And I don't know why you would do that. This is the way you should have done it. So 3 points. That was letter A. How many gallons of water are in the tank at 3 minutes? Okay. This is just a pretty straightforward thing. You know, and I think to myself, this is really a case of 3 things, okay? You have the water that was in the tank at 0, the water that's pumped in, and the water that has leaked out. And you actually know all these, if you think about it. Because at time 0, you know that there's 30 gallons in the tank. So I would probably write this. It's, you know, and they don't have a function name, do they? So I would say water at time t, okay, where is gallons in tank at time t. Water in tank is equal to water of 0, do you agree? Plus the integral from 0 to t of 8 dt. Because it's coming in, it's being pumped in at 8 gallons per minute, minus, all right, move this up a little bit, minus the integral from 0 to t of t plus 1 dt, agree? Well, for 3 minutes, we know this is 30 gallons. We know for t equals 3, do you guys agree this is just plus 24 gallons? Right? I mean, 8 times 3. 8 gallons in each minute. And finally, the leakage is 14/3 from problem A, right? Gallons from A. Let's see, did I do it right? Oh, looks like I did. And the answer is 148/3 gallons is what you should say, right? You should put the units. The point here is only 1 point. The point was simply for the answer for 148 thirds. All right? That is all. It's just for that. So again, so now think about it. We've done 2 parts of 4, and we have 4 points. So there's still 5 points to be had here. Write an expression for A sub t, the total number of gallons of water in the tank at time t. I guess I should have read the whole problem. Maybe I should have used A sub t, because guess what? My argument is I have that function. I bring this one back down and make it big. They want me to use A sub t. So if I do that, do you guys agree A sub t is equal to A sub 0 plus the integral from 0 to t of 8 dt minus 0 to t of t plus 1 dt. Now, they're not going to want you to leave A 0, okay, for this one. They're going to want you to put in the numbers you know, okay? And I think we know that, so our A sub t equals 30 plus, and remember our limit, or our integral rules. Since these are the same limits on both of these integrals, I'm going to go 0 to t of 8 minus the square root of t plus 1 dt. And that should be the function. And it is, okay? And actually both methods would have been probably correct. They also do an antiderivative method, but this is really the easiest way to think about this problem. So again, 2 points for here. One for the 30 plus 8t, or this integral here. And one for the 30, for the initial condition, okay? So there's 2 points. So that leaves just 7, right, total now? So it leaves 2 for the part B. All right. Now what time t from 0 to 120 is the amount of water in the tank at a minimum? All right. In part, well, maximum, just by your answer. Think about it. We created an expression. Do we agree? So again, I'm going to leave C big, I guess. I bring it back down. Do you guys agree we have, right here, an expression that gives the gallons at any given time t? Right? If I want to maximize that, find its derivative and its critical points. Fundamental theorem right here, right? We're going to take the derivative of this. So I'm going to find A prime of t for part D. All right? Derivative. Yeah, so 0. I'm not even going to write it. And what's the derivative?
0.
What's 0? Not 0, remember? It's just the, that's already the antiderivative of this, so it's just this, and then derivative of t is 1, right? But I won't do that, okay? So that is the derivative. So now I got to find the critical points, right? So I set A prime t to 0, and I write it because there's a chance that that's worth a point, right? And I get 0 equals, and then I do some math here. I move that to the other side. I get t plus 1 equals 8. Square both sides. T plus 1 equals 64. So I get t is 63 minutes. All right? That's a critical point. Do we agree? So now, we have to show that this is a maximum. How are we going to prove this is a maximum? How do you want to do it? A couple ways. We should be able to name both ways we can prove this is a maximum. First derivative rule is one way to do it, which is probably the way I would do it, but what's another way?
So they won't accept it, but
Yeah, you can't How about the second derivative rule? So we do first derivative or second. And when you look at this derivative, a prime of t right here, you got to ask yourself, is it easier to show, since it's a maximum that's going positive and negative, or is it easier for me to quickly take the derivative here and prove that it's negative? Okay. This case, well, second derivative would be negative, right? Second derivative rule. Second derivative.
Oh, you're right. You want it truncated down.
Down.
For your max.
And look, since it's 8 minus the square root of t plus 1, think about the derivative. You know it's going to be negative, right? Because you got the power. So I might be tempted two ways to do it. When I look at the answer sheet right now, they do it by saying a sub prime goes from positive to negative. All right? So you can do that. You can say a sub t less than 0 for 0 to 63, right? A prime of t is greater than 0. Oh, I'm sorry, I did that backwards. Greater than 0, less than 0 for time greater than 63. Thus, by first derivative rule, right? There is a maximum. This is what the AP test shows. Truth is, we're allowed to do whatever we want. All right? I might have been tempted to quickly take, it's written blue, to quickly take a prime of prime of t as negative 1/2 t plus 1 to the negative half. All right? And I can quickly say that the second derivative is negative at t equals 63. Thus, it is a maximum. It is a second derivative. Okay? Either way, both those will be right. You get a point for setting at to 0. Oh, I called that, didn't I? You get a point for solving for t, getting 63. You get a point for your justification, one of those two reasons.